The Mariana Trench is the deepest spot on Earth, located in the Pacific Ocean and plunging down 7 miles. Our planet, which is 4.5 billion years old, keeps changing and amazing us. Continents shift, volcanoes erupt, and glaciers grow and melt, shaping breathtaking landscapes. What secrets could this deep, dark place be hiding? Come along and discover more about the incredible wonders of the Mariana Trench and what lies beneath the sea. But before we begin, take a second to hit that subscribe button. Help us grow this channel and spread the word of God around the world. Okay, let's get back to it. Revealing the ocean's hidden depths. Exploring the Mariana Trench feels like a journey into the deepest corners of our planet's oceans. This place isn't just deep, it's full of wonders, with scientists tackling huge challenges as they dive into these dark waters. They're like detectives, working to uncover which mighty natural forces have shaped this hidden underwater world. Deep down, they've discovered amazing sights like erupting underwater mountains, strange mud volcanoes, and the Earth's biggest geological feature. What they find in this one-of-a-kind underwater place could completely change how we see the way Earth forms and reshapes itself over time. Hidden away in the Western Pacific, the Mariana Trench is the deepest spot in all the oceans on Earth. The search to understand how this deep scar in the Earth's crust was formed and how it still shapes our world began way back in 1872. That's when a British ship, the HMS Challenger, set out on a bold mission to chart the ocean floor. Before that, people thought that if you went deep enough, the ocean was just flat, dull, and empty of life. They didn't expect to find anything exciting. The Challenger and its crew spent 4 years sailing about 70,000 miles. That's nearly a third of the way to the moon. Every 140 miles, they would check the depth with an enormous amount of rope, 249 miles of it, and lots of lead weights. It was hard, tiring work, but back then it was the only way to learn how deep the ocean really was. When they reached a spot in the Western Pacific, 200 miles from the island of Guam, they kept lowering their rope, waiting for it to finally touch the bottom. But to their surprise, it just kept going deeper and deeper. It was a huge shock. Nobody had imagined the ocean could be this deep. When the weight finally reached the bottom at 4,475 fathoms, nearly 5 miles down, it raised tons of new questions. What had they stumbled upon? Was it just a small dip? A giant hole? Or something else entirely? Finding this spot sparked a lot of curiosity about what else might be hidden down there. This journey by the Challenger is seen as the beginning of modern oceanography. It gave us the first rough map of the ocean floor, showing how it slopes away from land and then falls off into wide, flat plains. But the Western Pacific was different. Here, the ocean floor suddenly plunges into a trench 5 miles deep, completely changing the old belief that the ocean bottom was flat and boring. It would take another 75 years before we started getting some real answers. That's when a new tool called sonar came along and took ocean exploration to a whole new level. Sonar first came about to help find submarines during the early 1900s and got much better by the 1940s. It works by sending sound waves through water. These waves bounce off objects in return, and by timing the echoes, scientists can map what's below. Using sonar turned out to be way easier and cheaper than having sailors pull miles of rope. In 1951, a British Navy ship with this new sonar gear went back to the deep spot the Challenger had found. The results were incredible. They made detailed sonar maps and learned that what they thought was a hole was actually part of a giant trench, 30 times deeper than the Empire State Building is tall. This trench stretches over 1,500 miles, about twice as long as California, running from southeast of Guam to northwest of the Mariana Islands. People must have been amazed by what they found. The ocean floor wasn't just flat. It was packed with mountains and valleys. For a geologist, this was incredibly exciting. The trench itself had so many unique features. At its southern tip, it plunges another 2 miles deeper, reaching an incredible 7 miles below the ocean's surface. Scientists had discovered the deepest spot in the ocean, still the lowest known point on Earth today. They named this place Challenger Deep to honor the ship that first found it. To really picture just how deep this trench is, imagine dropping Mount Everest into it. You'd still have about a mile of water over its peak before you'd even begin to see the ocean's surface. But how the Mariana Trench actually formed was still a mystery. Researchers realized the best way to learn more was to go down and explore Challenger Deep themselves. But this was no easy task. At the bottom of the trench, the pressure is so extreme, it's like having 50 large airplanes pressing down on you from all sides. Up next, we look at a historic and brave mission that set a new record in underwater exploration. Extreme pressure of the deep sea. To show what this kind of pressure can do, scientists ran an experiment with a styrofoam head. They're planning to place one of these heads, normally used to display wigs, into a pressure chamber to mimic the deep ocean conditions of the Mariana Trench. That's around 16,000 pounds per square inch. If it were a real human head, it would be completely crushed. But instead, the styrofoam head gets squeezed, shrinking a lot. It's quite something to see. To give you a sense of it, they compare it to the head's original size, and the difference is huge. It really shows just how extreme the pressure is down there, and it's a good thing humans don't have to face that kind of force. Protecting people from such brutal conditions was a major challenge for the engineers. Back in 1953, a Swiss scientist named Auguste Piccard came up with the design for the Trieste, a deep-sea sub that could handle those crushing depths. The Trieste had a long 50-foot body filled with light aviation gasoline and heavy lead weights to help it stay steady underwater. Underneath, it had a small, round cabin just 6 feet wide with thick steel walls to keep the massive pressure out. After 7 years of adjusting and testing, including several manned dives that didn't go deeper than 3.5 miles, the Trieste was finally ready to go the full 7 miles to the trench's bottom. The person in charge of this bold mission was a U.S. Navy lieutenant named Don Walsh, a skilled deep-sea explorer. The project was kept quiet because only a few top brass knew about it. The dive began in January 1960 from Guam, which was pretty remote at the time. Perfect for a low-profile but risky mission like this, as the Navy really didn't want public failure. Joining Walsh on this historic dive was Jacques Piccard, the son of the Trieste's creator. The two were packed into a tiny freezing sphere, about the size of a big household fridge inside, for nearly 9 hours. They were heading down to explore one of the most remote and extreme places on Earth, the Mariana Trench. Their slow journey into the deep started at a speed of just 3 miles an hour. As they went farther down, around 3,000 feet below the surface, they were surrounded by total darkness, where no sunlight could reach. The only light came from the Trieste's strong lamps, and now and then flickers from sea creatures that glow on their own, like underwater fireflies. This mission was more than just a technical feat. It was a daring dive into one of Earth's last unknown places. Inside their solid steel sphere, Walsh and Piccard passed their earlier record of 18,000 feet without any trouble. Everything seemed to be going smoothly. They were safe behind 2 layers of glass at the back of their cabin. But about 2 hours into the dive, a loud bang shook them. The outer glass layer had cracked. Now they were nearly 20,000 feet down, quickly checking their equipment and the cabin for damage. Their tiny capsule, made to protect them in extreme conditions, was now under even greater stress, with a crushing 8 tons of pressure per square inch. With the outer glass gone, only 1 layer was left between them and instant death. The situation was serious. If the inner glass broke, it would be over. But somehow it held firm, and the two chose to keep going deeper. As they continued for almost 5 more hours, tense and focused in their small, cold cabin, they got closer to the trench's floor. Just when they thought they'd seen everything, something moved across the ocean bottom. A flatfish, about a foot long. Spotting a fish at this amazing depth was surprising and exciting. It proved they had reached their goal, the lowest point of the Mariana Trench. The depth gauge showed 35,800 feet, almost 7 miles down, exactly matching the sonar readings. Now we take a closer look at how this massive trench formed and the powerful forces that shaped it. The record-breaking deep-sea dive. Here, so far below the Earth's surface, they paused to take a self-portrait, marking their historic achievement. But their mission wasn't just about getting to this point. It was also about studying and recording the trench's unique features. Sadly, their sub stirred up a cloud of fine sediment, making it almost impossible to see anything. It felt like being inside a bowl of milk. That's how bad the visibility was. Knowing they couldn't complete their observations, they chose to return to the surface. After a tough 9-hour journey beneath the sea, the Trieste surfaced off Guam on January 23, 1960. Walsh and Piccard had done more than just survive. They had set the record for the deepest manned dive. a record that still stands today. This dive was a remarkable show of human bravery and engineering skill, and it marked a huge step forward in ocean exploration. Still, their success left big questions about how such a massive trench came to be. If they couldn't find the answers deep in the trench, they'd have to search elsewhere. In the 1950s and 60s, led by Princeton's Harry Hess, a group of geologists began studying sonar data from oceans across the world. They carefully mapped the seafloor and found that the Mariana Trench was part of a giant network of undersea canyons stretching across the globe. They also discovered something just as incredible: the East Pacific Ridge. This underwater mountain range, running alongside the trench on the opposite side of the Pacific, was part of a 40,000-mile-long chain of mountains, making it the planet's largest geological feature. This was a major breakthrough. It hinted at a possible connection between the trench and the East Pacific Ridge, which needed more study. The clue came from an unexpected place. During the Cold War, the U.S. had set up a massive network of underground seismometers to track atomic bomb tests worldwide. These tools also picked up natural earthquakes. When scientists plotted these earthquake spots on a map, they saw they lined up along the ocean ridges and trenches. This pattern was a game changer. It completely transformed how we see our planet. It showed that the movements causing these earthquakes were happening deep below the ridges and trenches. Thanks to this huge network of seismometers, scientists could now pinpoint exactly where earthquakes were happening, how deep they were, and what type they were. This detailed data gave key insights into how plate tectonics work, changing our understanding of how the Earth's surface behaves. A bold new idea began to reshape what we thought about our world. The Earth's surface isn't one solid shell. It's broken into giant sections called tectonic plates. These plates are always on the move, sliding past each other, bumping into one another, and sometimes pulling apart. This movement is what sets off earthquakes. Where these plates meet, you find deep trenches and tall ridges on the ocean floor. Two of the most important are the East Pacific Ridge and the Mariana Trench, which sit on opposite sides of the Pacific Plate. The effort to figure out how the Mariana Trench formed has uncovered more clues and facts over time. The Trieste sub went all the way down to the trench's deepest point, proving it's the lowest place on Earth. After that, sonar helped map the nearby East Pacific Ridge. To understand how the trench formed, scientists had to look at what was going on at this ridge, including studying the giant underwater mountains, some 8,000 feet below the sea surface. We now understand more about the Mariana Trench because we've mapped it along the western edge of the Pacific tectonic plate. Across from this trench, on the other side of the plate, lies the East Pacific Ridge. This ridge is part of a vast underwater mountain chain, the largest geological feature on Earth. Scientists thought that this huge ridge might hold the key to understanding how the trench came to be. They found an important clue far away, where the ridge runs through the middle of the Atlantic Ocean. Next, we uncover key evidence that shows how the Earth's crust forms and shifts. Strange magnetic patterns. Under the sea, during the Cold War, the U.S. Navy came up with a way to detect Soviet submarines using a device called a magnetic anomaly detector, MAD. This gadget could spot the metal hulls of subs deep underwater. But what they found was something surprising. Along the ridge, there were odd bands of magnetic rocks that showed a pattern, alternating between positive and negative. People often describe these patterns as looking like zebra stripes. Scientists knew that Earth behaves like a giant magnet with north and south poles, but those poles don't stay in one place forever. Roughly every 300,000 years, the magnetic field completely flips. That means a compass that once pointed north would suddenly point south. This flipping of Earth's magnetic field is a strange and fascinating process that's still tricky to fully explain. Scientists think this is what causes the striped magnetic patterns seen on the ocean floor near the ridges. In the 1960s, it was revealed that molten rock, called magma, rises up from deep within the Earth and builds these ridges in both the Atlantic and Pacific Oceans. When this magma rises between the tectonic plates, it pushes the ocean floor upward, creating those huge mid-ocean ridges. While the magma is still hot and flowing, its magnetic particles align with the Earth's magnetic field at that moment. When the magma cools and hardens, these particles stay locked in place, recording where the magnetic poles were at that time. As fresh magma keeps rising, it pushes the older crust farther from the ridge, capturing each flip in the Earth's magnetic field. This pattern of magnetic reversals works like a natural tape recorder, storing these changes in magnetization. The magnetic stripes let scientists measure how fast the tectonic plates are pulling apart. The stripes prove that the ocean floor in both the Atlantic and Pacific is spreading outward from these ridges at over 2 inches a year. But geologists needed stronger evidence that magma was really building the ridge. If hot molten rock was creating this giant mountain chain in the Pacific, the nearby water should be warmer. In 1977, a group of scientists set out to see if that was true. Dudley Foster led these daring dives. It's always exciting to be at the cutting edge of science, discovering something new each time you venture out to sea. Every trip brings a fresh group of scientists and new missions, and it's the thrill of exploring and discovering that makes the work so exciting. For weeks, a team of explorers searched the deep ocean ridges without finding anything unusual. Then out of nowhere, they came across something incredible, a tall rock spire releasing a stream of hot toxic gases into the water. Around it, the water shimmered and bubbled almost like a clear kettle coming to a boil. Curious, they measured the temperature and found it was around 38 to 39 degrees Fahrenheit, much warmer than the chilly deep sea, which usually keeps temperatures steady and cold. This strange rock structure, called a hydrothermal vent, was a major discovery. It showed that heat from magma deep within the Earth was escaping at the ocean floor. But instead of spreading out evenly, this heat was blasting through these vents, forming pockets of warm water. Sometimes when scientists make discoveries like this, it takes years to realize just how important they are, and this was one of those times. These hydrothermal vents turned out to be a key piece of the puzzle about the Mariana Trench. They proved that magma was constantly building new crust at the Pacific Ocean ridge. The discovery of magnetic zebra stripes on the seafloor showed that old crust was being pushed away from the ridge toward the Mariana Trench on the other side of the Pacific Plate. This raised a big question. If new seafloor keeps forming, but Earth isn't getting bigger, where does the old crust go? Scientists soon saw that as new ocean floor spreads out, an equal amount must be sinking back into the Earth somewhere, and the evidence pointed straight at the Mariana Trench. So is the Mariana Trench just a deep underwater canyon, or could it be hiding secrets that could change what we know about Earth? Share your thoughts in the comments, and don't forget to like and subscribe for more.